All right, guys, welcome back. So I showed us how to build an ERC-20 token. So in this service, I'm just going to walk us through the code we build line by line. I explained to you how everything works under the hood so that you understand it better. And also, I've created an interface for the code we wrote to get. I'll walk you through the interface so that you understand how everything works. So stay with me. Okay. So let's understand how everything works line by line. So I'm going to explain the code line by line as I told you. So I've added a bit of documentation yet to tell you what's happening. So this code I will still make it available in the GitHub so that you can as well access it and the rest. So I think okay. So first of all, we have our state variables. So one of the state variable we have the token name, the token symbol, the token decimal, and the total supply. Now Solidity is just a statically typed language. So that means as you are defining your variable, you need to state the type of variable it is. So if it is string, so that means if it's string, so that means you typecast it with the string. You add the string keyword to it. Then you also need to specify the visibility. So in Solidity, we have 4 key things. We have the private, we have the public, we have the internal, we have the external. So private means that it's only accessible within the contract. So we can decide to make it public. Yeah, public means that it can be accessible where. Then internal means that it can be accessed in the contract and also in the chart contract. So any contract that inherits that contract can access it. And external means that it's only accessible from outside the contract. So within the contract, you can't access it. Yes, so but more on that. So more on that. Then these are the state variables. Now we have another state variable we call the uint. So this uint is telling you that this guy is going to take number, which is an integer. When you say uint, so that means unsigned integer. Unsigned integer. When you say that something is unsigned, that means it doesn't have a negative or positive sign to it. So that means uint we only take positive numbers. Now, if the total supply I'm looking at to get, maybe I'm looking at getting a negative number, then I will make it uint. Yet, but I'll make it an int that is signed integer. So, but since it's going to be positive, we make it unsigned. Then we have an address type. You know, in Ethereum blockchain, we have 2 types of accounts. We have the smart contract accounts and we have the EOS, externally owned accounts. Like the contract you are seeing is type of a contract account. Now the EOA, the externally owned account, they have private keys and addresses, yeah. But your smart contract just have the code, yeah. So address in the blockchain network are unique. So what this address owner is telling you is that whoever that deploy these contracts are said to be the owner, will be the owner of the contract. So that means there are some things the owner might be able to do, then whoever that is not owner can't do it. So we are going to see the importance of this owner variable as we go for that. That is when we'll be looking at modifiers. Yeah. So I'm going to give some rights to the owner to do some things, and someone who is not owner can't be able to do that. Then I have something called immutable owner. So immutable is still part of the keyword. So what this immutable is telling you is that you can only set this owner once. So that means you can only set it once. Once you set it, you can't change it again. Now you need to actually know the, will I say, the second or the law, what you want to do in your contract. So if I want to be able to transfer ownership of this contract to another person after deploying this contract, so that means I don't need to set the owner to be mutable. But since I want to restrict the ownership to this address that deploying it, so I'm making it immutable. So you can't transfer the ownership. And you know that once you deploy a smart contract, you can't change it. Though we have upgradable patterns, that you can actually use to, but that is more of that. That's more of that. I'll brief us when we get there. Now we have a mapping. So like I told you, mapping is a kind of key value pair. So given the key, you can know the value. So give me the password to your account. I can access your account. Yes. So what this, so the balance, it holds the balance of an account on the contract. So if any account on this contract, so the balances mapping holds it. So mapping is one of the data structure, or one of the, will I say, yeah, one of the data structure or variable types we have. Yes. Now, so for you to access a map, you need to have the key. So this is the key. For here now, address is the key. Like I told you, the address is unique. So once you have the address, you can get the amount. So you need the address to get the amount. So you need the key to unlock the amount. So use the key to unlock the amount you get. So like what you have here, I named my mapping, you get. Though there are some mapping you see, but it's not named, you get. For me, I like to name my mapping so that maybe if I come back next time, I actually look at the code, I know what is happening. So I like to name my mapping. So this part of the new things brought into the new Solidity version. So in the new Solidity version now, you can be able to name your mapping. Then we have another mapping. This is what we call nested mapping. So this is mapping inside another mapping. So this mapping is for the allowance. So it holds the amount an owner approves a spender on his behalf. Remember, when we are looking at the transfer form, when I gave you the instance of giving you a check, get. So this is the address of the owner. This is the address of the spender. This is the amount. So that means once I call these allowances with the address of the owner as the key and the address of the spender as the key, I can actually get the amount that is stored in this data structure. So that is pretty much about what this line of code is doing. So then we now go to events. So I've added some Netscape documentation using the Netscape type to actually tell you what is happening. Yes, so I'm telling you that, okay, this is going to emit amounts of token moved from one account, that is account from to another account to. Get, and he says that this amount might be zero. But if you remember carefully the logic implemented for the transfer, we did something that makes sure that the distance can be zero. So that means you can actually remove that logic, that required statement. So that is up to you. So if you remove that required statement, that means you can actually send zero value to someone. But that's about that. So this is how we define events. Now, these events, they are not stored directly on the blockchain surely. They are stored in special data location we call logs. Yes, and this event, for guys that understand front-end, this event, they are very useful. Yeah, they are very useful in your UI. So maybe when you perform a transaction or you execute an action or call a method, you want to give the ordinary user, tell an ordinary man out there what is happening, because an ordinary man doesn't understand the smart contract. Yeah, but through this event, you can actually tell them, okay, this is what is happening on that good. This is what happened. And it's also advisable, in blockchain, we have two actions you can perform. So it's either you are reading to the state or you are writing from the state. So reading from the state means that you are not making any state change. You are not changing anything. So that means you don't pay for gas. But when you are writing to the state, that means you are making a state change. You are changing the state variable or changing the world state. Yes. And doing that, you pay for gas. And it's advisable that anytime you are writing to the state, you should use an event. That is one of the, one of the standard, or one of the good practice when designing your smart contract. Anytime you are writing to the state, you should use an event so that you tell what happens. You get. So that is more on that on event. So you can maybe look up some resources if you still want to get more insight on event, or you can also drop comments in the comment section if you don't understand the event. Maybe I might still do a different video explain events in depth, because in some events we also have in some events we have something called indexing. You get. So when you index an event, that means you've given it a special, we like to say a special reference, or we call it parameters, and you can only index three. You can only have 3 index parameters per event. You get. So more on that. So these are some events I put them. Also, I created. Okay, don't worry. Now we have a function we call modifier. So what this modifier does a lot of things in your code, you get. But looking at the name, this modifier says only owner. So that means what I want to do in this function, I want to allow only the owner of this contract. Remember, there's an address. There's a data type we defined as address, which we set as the owner. Now I'm giving a preference. to the owner, right? So wherever I use this only owner means that only the owner of this contract can call that function. Only the owner of this contract can call that function. So you are going to see this more when we enter the mint and bond token function. So in part 1 of this, I walk us through how to create ERC-20 token from scratch, you get, using the standard. Then an app added mint and bond. So mint and bond are not part of the standard, but I just added them so that should in case you want to mint, because if you check very well, you discover that when we are creating the token, there's nowhere we specified maybe the amount we want to create at the moment. So I want to make it dynamic so that I will not have the mint function that actually mint and bond token. So I will show you how it's done. It's just simple logic you get, but I walk us through the standard first, because you need to implement the standard first before you now bring in your own logic. Get. So you are going to understand this modifier. Okay, another use case of this modifier is when you want to reuse logic. So let me quickly show you what I mean. Like those places we are having some checks. Like if you watch, you might see that maybe some of the check we have for the transfer, some of the required checks we have for the transfer, if they are the same with the required check we are having for the transfer form, yes, if they are the same. So instead of having it multiple places, you can just put it in modifier. So in that, you are making your code dry. So you are reusing logic instead of, so make your code monitor. But I just left it like this so that you understand how everything is going under the hood. But on my own, I like to use modifier, reuse code, and make everything clean. So that is another use case of modifier in your contract. Then let's go to functions. So we have the constructor function. So the constructor function is only run once. So during the contract initialization. So I've added some comments. So this comment is telling you what is happening. Okay, this parameter, what is this parameter doing? What is the work of this parameter in this function? So that is why I have that param. Then dev. So the token name, token symbol, and token decimal. So sorry. And token decimal are provided upon deployment. So this is just trying to tell whoever that is developer that is trying to use this, maybe because you created an interface for this, you get. So whoever that is trying to use this interface or that wants to interact with this, you actually know what is happening, you get. So, and like I told you in part 1 of this video that I made this guy dynamic. I made the token name, token symbol, and decimal dynamic. So I can decide to hard code it. Hard coding it means that I might not have constructor. Yeah, so what constructor does, this is a function that runs only once, and it runs only during contract initialization. Yeah, so in the constructor, so I use constructor so that I can be able to get dynamic input from the user. So that means a user can put in any value, like, so whenever anybody wants to deploy this token, you can give you your own name or give you whatever, instead of me hard coding the token name. So that's just why I put them, I pass them as parameters in the constructor. Now, after passing them as parameters in the constructor, I now did what we call variable initialization. So I initialize the state variables. So give them initial state. So that means whatever inputs that is coming in from the user, for the token name, set it to the token name. For the token symbol, set it to the token symbol. Then for the token decimal, set it to the token decimal. Then for the owner, remember, we have a variable called, we have a state variable of type address. We set as owner, which is this guy. So we want to set this guy. We are setting this guy to the owner or to the message or sender. So whoever that is calling to deploy this contract, whoever that is clicking on the deploy function, whoever that is clicking the deploy button automatically becomes the message or sender. Yes, whoever that is pressing this button, whoever that is pressing button to deploy this contract is the message or sender. So set that address that is clicking on this button to deploy this contract to the owner, that is to the message or sender. Yes, so that is what this line of code is doing here. So with this, you've been able to initialize your state variables and the rest. So now let's go to functions. So just like I told you, the token name is pretty simple. So it returns the name of the token. So the token name is stored as a state variable, which we define up here. Yes, so which we define up here. Then, all right. So look at the token symbol. So this guy just returned the symbol of the token. So once you call this function, return the symbol of the token for you. Then we have the token decimal. Now I return the token decimal for you. Okay, so the token decimal, you pass it like just as we pass it as parameter in the constructor. That means you are going to provide it upon deployment. Yes, so after this line by line walkthrough, I'm going to deploy and test these parts on Remis and show you how everything works again. But so maybe you can go through this code, this naked doc and actually understand how everything works. Yes, so token decimal of when you have 1 to 18,0 is the same thing as 18 decimal or 1E18. So that is just more about, I believe when you go through this more documentation I've put, you'll be able to get more insights. Yeah, I don't just want to waste your time in this video. Then we have the total supply. So it returns the total supply of a token we get. Now with the main function, we increase the total supply. So the total supply, we have it as a state variable we defined. Again, now the balance of, so it takes a parameter of address type account. You get, so an address on the contract. So it represents so the account represents an address on the contract, you get, which stands for the user or the owner. So once you call this function, pass it an address, it's going to show you the balance of the account. So how much the owner has. So just like me giving you if I give you my mobile app and tell you my password, which in this case is the key. So you can actually know how much I have in my account. I remember this balance is the mapping we defined up here. It's a mapping we defined in the data structure. Get, so this mapping, it holds the balances of an account. So that means once you call this, passing in the address as key, definitely you are going to get how much is stored in that particular address, how much of this token that particular address is holding. Yes, so that is the balance of, so pretty straightforward. So it returns the balance of an account. Then we look at the transfer. So the transfer is going to take two parameters. It's going to take the address to an amount. So if you want to transfer money to someone, you need to know the person's account number and also the amount. So that's pretty much what this function is doing. So no much logic here. Yes, so it moves amount. So the amount the user provides from the caller's account to the receiver, that is the tone. Get the caller is not the message or sender. So whoever that is calling this function, whoever that is clicking this button is the caller, is the message or sender. So whichever amount that person puts is going to move it from this person's account to the receiver account, which is the tone. And when it's successful, it's going to return a Boolean value indicating whether the operation is successful or not. And it's going to emit a transfer event. So one transfer event is one of the events we define, and I showed you. Get so now let's look at the logic for this guy. Get so it takes address to as parameter and the amount. Then it's going to do some CII check. Yes, first of all, we implement a require. So what this particular line of code is doing is that it checks that the address, the receiver address is not 0. So we make sure that it's how to protect it so that you not send the money you want to send or the token you want to send to a 0 address. The 0 address is like a dead address in the Ethereum blockchain. It's an address that is 000. So now if it checks, so how require works is that if this particular logic that is not equal to address 0, if this is successful, it will continue to run the next code under it. But if it is not successful, if this check fails, it's going to throw this error to you. It's going to give you this error that tells you that transfer to 0 address. So telling you that you want to transfer money to a 0 address is going to warn you. So once this check did not pass, it will fail and throw this error on the console or on the front end. Then we also have another check that requires that the message or sender is not a 0 address. So whoever that is calling, that is pressing this button, whoever that is calling this function, that will press the transfer button, this thing, is not a 0 address. Get so if it checks and it fails, it's going to throw this error. Get so that is just to, in summary, the syntax for require is that when you have a require, let me just, when you have a require, first of all, do security check. You get security. How do they even spell security? You do security check. So now if this security check pass, you continue. But if it fails, you give the person error. Give reason for the error. Give reason. Give reason for failure. Or error. Yes. So once it passes, it's going to give you reason for error. So this is just the syntax for the require. You get so here now we are checking that the amount is greater than 0. So the amount you want to send, we want to make sure that it's greater than 0. So if the amount is not greater than 0, it will throw an error and ask you to increase the amount. Then here we are checking that the balance of the message or sender. So the person that is sending, you want to check and make sure that me being the sender or whoever that is clicking this transfer button has an amount. So the balance in his account is greater than what he wants to send. And we have the balance of function which we defined above. So he's calling this balance of function. Remember, this balance of function, it returns the amount of token owned by an account. So it returns the balance of a particular address. So that is what is happening here. Yes, so it requires that the balance of message or sender. So message or sender, whoever that is calling this function, you need to, this message or sender is somehow tricky, but just know that whoever that press this button, if I have a button on the front end, if I have a button you are seeing that is called transfer, whoever that is pressing that transfer button is the message or sender. So you have to make sure that the amount the person has in his account is greater than the amount the person wants to send. Yes. So maybe we want to make sure that, okay, you want to send $100. You want to make sure that you have more than $100 so that you don't send more than what you have. Okay, so if that check fare is going to tell you insufficient funds, so the error message you put here is up to you, is up to the user. Now, if this check passes, remember the check effect interaction, the checks first. So if the check passes, then what you do is that the person that is calling this function, you have to subtract the amount from the person's balance. So you need to debit the sender, give the sender a debit alert. So if I'm sending money to you, my bank will give me a debit alert. So they will reduce the money from my account. So that is just what is happening here. Remember, the balances of is a mapping we defined above, and it contains it holds the, okay, let me go back. Don't worry, I'll take you step by step. I want you to understand everything. So it holds the balance of an account on the contract. Yes, so that is just what is happening here. Get? So that is just what is happening here. Okay, sorry. So subtract the amount from the balance of the sender, then the person I'm sending the money to, so credit the person, so increase his amount. So as I'm sending money to you, my bank will debit me and you'll be credited. So add amount to the person's amount. Now, like I told you in part one, this code we have in 163, the same thing as saying balances of the two address plus, okay, sorry, balances of two address plus amount. So this is the same thing. So the code in 163 is the same thing as the code in 165, but 163 just the shorter way of writing it. You get so when the whole interaction is successful, then we emit a success, so return true. So after returning true, then you emit a transfer event. Now, this success is return type. You know, when you are like Solidity is a statically typed language. So that means if you are returning something, you need to define the type of what you are returning. So that's why we have these returns. This return, and the type is a Boolean. So Boolean is a type in Solidity that takes only two values. So it's either is true or is false. So by default, it's false. Get so success is the name of this Boolean variable. Get so since everything is successful, then that means we are setting the Boolean value to true. Now, if the checks we have above fails, that means this Boolean value will be set back to the initial state, that is to the default state, which is false. So the default state for a Boolean value is false. Yes, so once this check pass, so you have to emit a transfer event. All right. So that is for the transfer function. So let's look at the approve. You get. So the approve takes in two parameters, the spender and the amount. So the address of the spender. So what this guy does is like he sets the allowance of the spender over the caller's token. The caller is the message of sender. The caller is the message of sender. So he returns a Boolean value indicating whether the operation succeeded, and is going to emit an approval event. Now, remember this allowance. All right, let's go through it. So takes the address of the spender and the amount, then returns Boolean. So this function is pretty much, there's no more, it's pretty straightforward. There's no big logic to it. You get so now remember this allowance is a mapping we defined above. So mapping of the owner to the spender, then the amount. So let me go back to the allowances mapping again. You get so this is the allowances mapping. So it's going to map the address of the owner to the address of the spender and the amount. So remember, I told you that mapping is a key value pair. So what is doing here is that it's going to take allowances. Yes, so for this to be valid, it's going to take allowances. The first key one, and key one here is address of the owner. Remember, I told you mapping is a key value pair. Key one, which is the address of the owner. Then to another key two, which is still another address, which is the address of the spender. So once he takes this, so once you provide these two keys, you can actually know the amount. So you need these two keys to get the amount. So that is just what is happening in that approve function there. Let's go back to approve function. Yes, so it takes the allowances of the message or sender, which is the owner. That is the first key, to the allowance of the spender, which is the second key. So once you've done this, you now set the amount. Remember, there's what we call CRUD operation. CRUD. You get CRUD. Sorry, let me stay with me. I want to explain something because I've used some CRUD operation here. CRUD, you get. So you need to, C stands for create. So we created a mapping. We created the allowance mapping as a state variable. So that is the create. You get. So you can also read from the mapping. R stands for read. Okay. U is for update. U is for update. And D is for delete. So these are the basic. These are the four operations. These are the main four operations we're doing in every mapping you are defining. So we've created a mapping. So what we are doing here is that So what we are doing here is that we are updating the mapping. Remember, we created the mapping as a state variable, which is this. So we are now updating it with the input that is coming in from the user. So that is the update. Yes, CRUD operations. Yeah, then once it's done, so this says that it has to return a Boolean indicating success of. So if everything is successful, so this Boolean will be set to true. But if it's not successful, it goes back to the default state, which is false. Yes, so once the approval is successful, you have to emit an event telling them, okay, the approval is from this owner to the spender and the amount. So that is that about approval. Then let's look at allowances. So allowance is, it takes into parameter the owner and the spender of address types. So it returns the number of tokens that the spender will be allowed to spend on behalf of the owner through the transfer form. So this transfer form is another function. Just that function, I use the check to give you an instance. So, and this is 0 by default. So the value changes when I approve, okay, it's just more of, okay, the value changes when I approve or transfer a code. So what this means that if I allow you to spend 1,000 units of my token, right? So when you call this allowance function, you are going to see 1,000 as how much you've been allowed to spend, right? Now, when I now call transfer, if I call approve again, and approve you to spend 200, so it's going to overwrite that 1,000. So that means if you're not calling allowance now, what you now be getting is 200. So at any time you call the approve or the transfer form, it changes the state of whatever this allowance will return. Get. So that is just what this guy is explaining. So it will return the allowance. So remember, this allowance is that mapping, is that nested mapping. So given the key of the owner and the key of the spender, I will now know how much that particular address is allowed to spend. Get. So it's going to make more. You get this more when we start deploying and testing with Remix, but I don't expect you to get everything 100% at the moment, but that's why I want to do deploying and testing, showing you how it works in Remix. You get, I don't want to start building front end for it. You get, because building front end, I don't know if you understand front end, so I'll just show you with the Remix side. You get. So another function we have in our contract, the transfer form. So this is like the big guy that we actually want to give us some headache, but it's well. So, but this guy, he takes in 3 parameters. So the address from, so that is the sender. So this is the owner address. So who approved the spender gets address. So this is the receiver. So this is the spender. That is the account approved by the owner to spend the token on his or her behalf. Now, per amount. So this is the amount of token to be sent. Get. So this guy is going to move the amount of token from the to address. You get. He's going to move it from the owner to the receiver using the allowance mechanism. This allowance mechanism here simply just means the allowance mapping. Remember, we defined an allowances mapping. So that's just the allowance mechanism you get. So then the amount is not deducted from the caller. So if I have approved you and everything is successful, so if you now want to transfer, definitely the amount to be deducted from the caller allowance. And this guy is going to return a boolean indicating whether the operation succeeded or not. And he's going to fire a transfer event. Okay. So let's still go through the logic. So I believe by now you are conversant with these required statements. Yes, I've explained it. So the check you bring in is up to you. Yes, but there are some standard check you need to implement first. Yes, so we have the address of the tool, we have the amount, we have the balance. So now you have to carry out this check, make sure that it passes. So when it passes, I've explained this previously in the transfer. So I believe no need of explaining it again. But if you don't get explanation, just go back to my explanation in the transfer function. I don't just want to make this video to be long. Yet. So once every check is done, so what is going to be is that, remember, the allowance is whose the amounts and address is allowed to spend on someone's behalf. So if everything is done, since I'm calling this transfer form, so what is going to be is that if you go to this allowance mapping, that amount I've specified is going to deduct it from that allowance mapping. So it's going to remove it from that allowance mapping. So this is logical. If I'm sending money to you, okay, if I give you a check and you've gone to the bank to cash the check, once you cash the check, automatically they remove that amount from my account. So that's just it. So they've removed that amount from my account. Yes. Then the balance from, so the balance from, so which is me, the owner of the account, the amount will also be subtracted from his own account. So subtract the amount from the balance of the form address. So that means should they be the sender, then you add the amount to the balance of the to address. So you now credit the receiver. So you remove the address, you remove the amounts from the allowance mapping, debit it from the, also remove it from the balance of the owner, then credit it or add it to the balance of the receiver. That is the to address. So when everything is successful, you change the success state to true. But if it fails, the success state returns to the default value, that is Boolean, which is false. Yes. Then when everything is successful, you now emit a transfer event telling them, okay, so and so this thing has been transferred from this address to this address and this amount. So that is just what the emit does. So emit is what triggers the event you defined. Now these are just the ERC-20 token standard. When you say that something is a standard, so that means if you are creating an ERC-20 token, it must implement this first. So that's why it's called a standard. Now I've just implemented the mint and bond token function, but like I said, they are not part of the standard. So this thing is that if you're creating an ERC-20, first of all, you implement the standard, then you now bring your own logic. So that's just what I did here. You get, I created a mint token function. So this mint token function is going to take the address to and the amount. So to create new tokens, so you need to specify, okay, which address am I minting to? So we see this now. This is where the modifier comes in. Now I want to make sure that now everybody can see this mint function, but not everybody can call this function. So I want only the deployer, only the owner of this contract to be the one that can mint, because if I give everyone access to be minting, so that means anyone can just be minting to the address. So that's where this modifier we defined above comes into play. So it has some restriction. Is our modifier. Okay, the modifier it requires that the message dot sender is equals to owner. So if the message dot sender is not owner, it will tell you not owner. So we are going to see this by the time we start testing with Remix. We see how that guy comes into play. Get so that is just the check that is, so you have to first of all check that, okay, I'm not minting to a zero address. Get so now when I mint, so I'll add the amount to the total supply. Total supply is one of the state variable we defined. So I'll add the amount to the total supply. So that means without this mint token function, when you deploy your contract and click on the total supply function, it's going to give you 0. But when you've called this mint function, put in an amount and check the total supply, it's going to give you that amount you've put in. So that is what's happening here. So, okay, I'm minting. See, if I'm minting, whatever amount I'm minting, add it to the total supply. Then the balance of the minter, the balance of this to address, the balance of the person that mint, the address that minted, increase the balance by the amount. Again, increase the balance by the amount. Then you emit an event. So the mint function is just the same with the bond function, but the bond function is the opposite. You know, when you are minting, you are increasing the amount, you are increasing the total supply. But when you are increasing the balance and the total supply, but when you are burning, you are decreasing the balance and total supply. So when you mint, you increase the total supply, you add the amount to the total supply. But when you burn, you remove the amount from the total supply. When you mint, you add the amount to the balance of the message or sender. That is the balance mapping. But when you burn, you remove the amount from there. You get. Now the big question, or the question you might be asking yourself is, why do I need to mint and burn token? Now in cryptonomics, there is so there's some cryptonomics behind it. You get. So in economy, there's what we call scarcity. So scarcity gives an asset more value. You get. So when you burn token, what you do is that you reduce the total number of the token in circulation. Now, in doing that, you are going to increase the value, I say the market value, the price. So when you burn token, you reduce the supply, thereby making that means you have more demand and you have less supply. So that means the price will increase. But when you mint, you are increasing the amount of token in circulation. That means the supply becomes more than demand and the price might decrease. So it varies, but these are just some function you might implement. You get. So these are just the basic function I feel like I should implement. But on you, as you go through this code base, you can decide to bring in more functionalities and the rest. But this is just this all we want to. So this video is already long, so I'm going to cut it. So in the next video, I'm going to show us how we now deploy and test everything on Remix and see that it works. Okay, this particular code, I'll make it available in the GitHub. I think I've pushed it to the GitHub. Let me get the link. Let me get the GitHub link. Mhm. All right, so you can actually see the code. The code base is here. So yeah, so with the code base, you can actually access everything. Right. So see in part 3 where we now deploy and test